Hello and a very good morning to my fellow friends and lecturers. Today we are from Group 9. We'll be presenting our project or our topic, which is Risk of Gas Hydrate in Oil Production System. I am Muhammad Azri Adham Rahim, and she's Putri Balkis bin Sudirman, and lastly, Stewart Hilaris Anak Sanggalang. Okay. Introduction. What are gas hydrates? Gas hydrates are commonly known as clarates, means a hydrocarbon compounds that are trapped like a cage within water molecules. It was formed under high pressure at low pressure typically. First mentioned during 1930s by Hammerschmidt, formation risk increased due to higher demand in oil and gas production. Recent years, focus was more on identifying the correct thermodynamic phase boundaries of its formation. Gas hydrate formation within a pipeline are usually a hindrance. Right. Scope of topic.
So next, for the scope of topic, in this report, we are discussing about the risk of gas hydrate formation in upstream sector, which is during the operation, drilling operation, and also during the production process. Next, the risk of gas hydrate formation in midstream sector. If a company decided to use gas hydrate as a transportation means, then the technological advances following with the current issues regarding to the risk of gas hydrate. It talks about the effect of gas hydrate in a system, the environmental effect of the gas hydrate, and oil and gas accident that caused by gas hydrate formation. Then we also talk about how some countries like China, Japan, and in Europe is exploiting gas hydrate as an energy resource. Lastly, is about the hydrate formation process in pipeline and offshore, and how is it formed and its safety recommendations. So then.
Discussions, risks, technological advances, current issues, moving forwards, and many more. Hydrate formation pipeline occurs during stagnant fluid movement, aid with high pressure and low temperature. Fluid possessing highest methanol concentration usually will cause hydrate formation. More frequent happenings during startup operation. Most flow line of oil production nowadays usually are well insulated, preventing hydrate formation. This is a diagram showing how hydrate formation or plugs exist or created within offshore environment. So typically, you will have a downhole safety valve, and then the fluid will enters it through it past the expressly, and then usually the hydrate formation will happen in this area where it makes contact with the cold seawater bed. That's why hydrate formation is frequently happening here, and also sometimes here, between here, where more the fluid movement is very slow. Right. Next, this is a typical diagram or explanation showing how hydrate plugs form within oil production. So as there is three phases, gas, oil, and water. As time passed on, when it's flowing slowly flowing, hydrate shell will grow, causing the oil to oil, gas, and water to agglomerate, making a crystalline structure that finally turns into plug, which causes obstruction of flow. This is a diagram showing hydrate plug formation in gas condensate system. As you can see, within the flow line, which is the pipe, the first phase starts with the build up. Build up means that clarets or hydrate formation will build up around the circumference of the pipe, and then as it gains more agglomeration accumulation, it will form a restricting vein like effect that causes uh, hydraulic plug, hydrate plug. All right. So this is for high water volume system. This is a hypothesis because uh, finding hydrate formation in high water volume system is quite rare and haven't been extensively researched. Okay. Safety recommendation during hydrate formation. We need to obtain precise location of the plug to prevent one-sided one-sided dissociation. Fix plug problem ASAP. Do not delay it because it can cause major problem as the time went on. If depressurization option is not available, heating the plug electrically is possible, but take extra precaution to prevent explosion or fire.
Okay, continue with the risk of gas hydrate formation in upstream sector. So gas hydrate can form in high pressure, low temperature, low light gas concentration, and also high water concentration. The risk to the production pipe string will cause the low gas production rate and the variable temperature environment along the wellbore. The pipeline pressure holding accident is it is by the hydrate formation and pipe string deposition will directly reduce the fluid passage, fluid flow passage, and pipe string blockage. The blockage in tubing during drilling operation, it will be get interrupt during the operation of blowout preventer BOP and VOP. And then little to no circulation in the pipeline. The orifice, kill line, choke valve, or area adjacent to the BOP will be affected. The equipment that is under the seawater, it will be affected by the environmental condition, which is low temperature and high pressure that can form gas hydrate. The lastly, the flow lines that are transporting the product will cause the amount of time to expose to the heat transfer, causing the unexpected operational and safety issues. Then, for the risk of gas hydrate formation in midstream sector, risk of hydrate of or natural gas hydrate due to the high volume of transporting natural gas through a pipeline in a high pressure and low temperature. The internal walls of pipelines for transportation will form hydrates affected by the presence of hematite or rust. It can act as a water absorption site or can act as a catalyst to form the hydrate. The need to determine the maximum amount of water permitted in gas stream during processing or pipeline transport to ensure the gas hydrate to be prevented. Then, for the technological advances, first for the high fast 2. High fast 2 is an upgraded version from high fast. The high fast is the previous version, which is high fast, is to determine the hydrate plug formation algorithm and can rapidly evaluate the severity of a given system. While for the high fast 2, it is able to describe the phase equilibrium, particle size, aggregation, potential slurry relative viscosity, and also the frictional pressure drop for a multi-phase flow. High-fast tool able to execute for only 5 seconds for a 5 kilometer flow line. Then for the CSM high-fast A is a combination of CHM high-fast plus CHM high-K Olga. The CHM high-fast employs the mathematical modeling to solve the mass conservation equation in conjunction with the energy balance. Then for the CHM high K Olga is a transient multi-phase flow simulator that makes use of empirical correlations for the void fraction, pressure drop, and flow regimes. Then the CHM high fast A able to calculate the hydrate plugging rate assessment which is very simple and fast in calculating the hydrate and also processing the flow assurance. So this is the simplified algorithm of high pass through. The users need to input parameters such as the pressure, the temperature, the composition, and oil phase viscosity. So the the software will calculate in consist of nested spatial loops within a period of time. The computing results will be uh, the output result will be the phase fraction, pressure drop, and measure of the plugging rate. So next, so is the CFM high pass A. The users need to input the liquid loading, water cut, initial temperature, pressure, the pipeline geometry, and the flow rate. The software will calculate, and then the output result will be the temperature profile, the phase fraction, pressure profile, and the hydrate plugging onset.
So as for the current issue, I will talking about the major concern in oil and gas industry. So as we know, gas hydrate will cause a flow assurance problems, which this problem can affect the oil and gas transportations into the facilities. Formation of gas hydrate inside the pipeline cause plug, and this will disturb the production operations, which affect the rate of uh, productions. Gas hydrate will form a solid uh, uh, that eventually will cause a blockage and create overpressure situation on the pipe. So this can cause damage on the pipe and blowout can occur. Um, so next, I will talking about an environmental impact by gas hydrate exploitations. So first, I will talking about also ocean acidifications. This ocean acidification can occur because the reduction of oxygen level. Uh, Next, the microbial anaerobic of methane will alter the methane and oxygen into the carbon dioxide. So this CO2 will alter the pH value of the oceans into acidic. So this pH value or acidic pH value will affect the marine life such as coral, oyster, clam, and etc. So this acidic condition of the ocean affect the reproduction process of the marine life. So as next, the climate change. Climate change can occur by gas hydrate through two ways, which are consist of nature activities and anthropogenic activities. Anthropogenic activities enable for the gas hydrate to dissociate due to changes in temperature in deep seawater. Natural activity involves motion of wave due to wind that can trigger the gas hydrate seepage. Too much of gas hydrate emissions into the atmosphere will cause the climate will cause the climate change. So this will lead the global temperature increase and cause the reduction of permafrost of Arctic. So as for the uh, current issue, we're talking about the conference of gas hydrate development as a future energy. So the first conference is known as non-equilibrium control of the formations and dissociations of gas hydrate in natural in and engineered systems. This conference was held in Hotel Galvez, Texas, by Gordon Research Conference in February 23rd until 20th, 2020. So basically, this conference will is a platform for oil and gas companies, government, and academicians to conduct discussions about control, evolutions, and destruction of gas, hydrate, and engineered system. So this conference also is a platform for the researchers to present their research paper regarding the gas hydrate control and exploitations. Second conference that I can mention here is a 10th International Conference on Gas Hydrates, which held in Suntec, Singapore Conventions and Exhibition Center, Singapore. It's supposed to be held in December 6 until 11 to 20, but due to pandemic, it will postpone into 2023. Uh, Basically, this conference is same with the previous conference, whereby this is a platform for the researcher to review on the research papers regarding the gas development technology over the past 3 years. Researcher and oil and gas company collaborate, and researcher present their paper regarding the gas headache control and exploitations. So next is about moving forward on gas hydrate development. So as we know, natural gas hydrate is also known as a combustible ice that considered one of the best unconventional energy resources for the future. Um, Gas hydrate is attractive energy resource because it is abundant. So in the whole world, there are around 3,000 trillion cubic meter of the energy storage capacity of methane hydrate. So each value of gas hydrate could be higher than approximated because different studies will use different type of simulation method, which will give a different simulation value result. So uh, moving forward, gas hydrate development for each country. I will give example gas hydrate development in Europe. So gas hydrate exploration in Europe, they will begin they begin with the gas hydrate basin modeling technology known as Petromod. This simulations software will simulate uh, the generation, expulsion, migration, and accumulation of gas hydrate in order to predict the gas hydrate behavior. So in this software also this applies seismic applications in order to detect the gas hydrate, which by comparing the standard 3D seismic and 3D peakable seismic method. So as for uh, in this research, it shows that standard 3D seismic show more clear detailed image of subsurface structure. Next, gas hydrate development in China. So China was a pioneer for the world's first solid well fluidization well testing for the natural gas hydrate for the shallow layer in the deep sea. So gas hydrate will break down into slurry by mechanical forces and go to the surface via riser. So gas hydrate dissociate due to increase in temperature and reduce in pressure. Uh, in this method, the submarine for excavations, hydrate sedimentation, crushing and grinding, slurry lift, seawater injection, sediment backfill, and power supply unit is required to conduct this uh, development program. So as for conclusions, gas hydrate is an abundant energy resources that have a good potentials as a future energy to fulfill the increasing energy demand. Gas hydrate abundant energy resource, but most probably engineers will always encounter uh, with gas hydrate problem. So controlling gas hydrate is still a bigger problem to handle by engineers as it can cause major problems such as pipe plugging, especially in upstream process. Gas hydrate seepage from the formation can cause a negative environmental impact. It is important to conduct gas hydrate mitigation techniques when the presence of the gas hydrate in the production system. Oil and gas company and researchers should cooperate to conduct research and development program regarding gas hydrate control and exploitations. Research and development is crucial for future gas hydrate developments and effort to exploit gas hydrate in safe and economic manner. That's all from us. Thank you.